Okay, next I want to look at the case where you actually end up getting two triangles with side-side angle. And so first of all, I'm just going to kind of draw my triangle here. So 56.3 degrees and 7.6 and then 8.3. So if you're going to test for the height situation, you want to put your angle in this corner with the side that's across from it where you know both of those. And you want to put the other side over here. So you have side angle. And then your height would be right down the middle, or the altitude. And so you would just take sine of that angle, 56.3, and then opposite over hypotenuse. And again, some people like to do that, but you're just going to end up multiplying those together. So you're going to get the height is equal to that 8.3 sine of what, 56.3, which ends up being about 6.9. And since this is shorter than this side, what that tells you is that there's actually two possible answers you could get. One answer is what I have out here already. Okay, this triangle that I drew, where this is an acute angle, that would be one possibility. But another possibility is instead of swinging this out, I could actually swing it in. And so I could have this triangle here where this is actually an obtuse angle. So if I swing it out, I'm going to get the blue triangle, which has an acute angle right here. If I swing that side in, then what's going to happen is I get this green triangle with this obtuse angle. Now again, I rarely pretty much do that, or never do that, to be honest. I just go ahead and do the law of sines and let the trig and the math tell me what to do. So I'm just going to re-sketch this here. I have my 56.3. The side that goes with that is what, 7.6. Here's my 8.3, which is what, side A. So angle A is there. Angle B is there. Sorry about that. C is here and little c is here. Alright, so I'm just going to set up on my law of sines. So sine of 56.3 all over 7.6. And then I have sine of A, 8.3, and sine of C, side C. Alright, so I'm going to start right here where I have some values. Alright, and so I'm going to do the math right there, do that proportion. So I'm going to take this sine times 8.3 and divide by that. And that's going to give me that the sine of A is equal to, let's see, what do I get? 0.90, let's see, 0.90858, and that probably keeps going there. So again, this ratio is awesome because it's between -1 and 1. So I'm going to go ahead and do the inverse sine to both sides. And I end up getting that angle A is about 65.3 degrees. And again, make sure your calculator is set on degrees. Alright, so at this point, I need to get angle C. Well, again, the nice thing is I know that angle A, or when it's out here anyway, is 65.3 degrees. So there's 180 degrees in a triangle, so I can just take 180 and subtract the two angles I know. Alright, and then whatever's left is angle C, which is 58.4. Right, and then the last thing I need to do is figure out side C. And technically these are kind of all approximations because I had to round, but again, if you use equals, not a big deal. Alright, and so I'm going to go ahead and just kind of erase this over here and just going to edit it again. So I have what? Sine of, what's this angle here? 58.4, and I don't know that side. Now again, A, I know that angle now too, is 65.3 degrees. I could use this cross multiplication, that's fine. I tend to like to go to the beginning just in case, I don't know, there's some rounding here and so forth, so maybe going to the beginning, but it really doesn't matter. But I'm going to go from here to here and there. So I'm going to multiply sine of 58.4 times 7.6 and then divide by the sine of 56.3. So let me do that quick. So I have the sine of 58.4 degrees times 7.6, enter, divide by the sine of 56.3, and I end up getting about 7.8. So C is about 7.8, and again, whatever your unit is there. All right, so basically, I now know all the angles and all the sides for that triangle right there. So I solved that one. Obviously, I already knew angle B, and I knew the other two sides. So I know all three sides, and I know all three angles. But I also know there's another triangle floating around there. So what I need to do is I need to go back to this step right there. When I hit inverse sine, that should be a dead giveaway, all right, that there might be two different angles, because we know in trig, when you do inverse sine, the original sine has two ratios or two angles that would give you this ratio. So when we do inverse sine, the calculator thinks you're limited to the right two quadrants, and that's not necessarily the case. So here's my unit circle, and I got an angle when I did inverse sine of what, about here, 65.3 degrees. All right, so that's that angle right there. Okay, and so I have some ordered pair value that fits right there. Well, the mirror image of that is right over here, and that's going to have the same sine value, because here I'm going over and up some positive distance. Here I'm going negative and up that same positive distance. So I also need to know this other angle, and I'm going to use green actually to kind of match, but I also need to know that angle right there, and I guess it's green. So I'll try that again. I also need to know that angle right there. And so if I look, let's see, this is also 65.3 because it's symmetric. So if I take 180 minus this guy, I'll end up getting that one. So 180 degrees minus 65.3 degrees. And if I end up subtracting those correctly, I end up getting what, 114.7 degrees. And so that is this obtuse angle right here. So if I redrew my triangle, I'd have my 8.3. And actually, let me try to redo that. So here's my 8.3. Here's my 7.6. Here's my original, which is what, 56.3. But now this angle is 114.7 degrees right there. Alright, so again, kind of like before, I know two of my angles, so the next step would be to take 180 degrees, subtract the 114.7 and subtract the 56.3, and see how many degrees are left for the other guy. And it looks like that's going to be 9 degrees. Okay, so let's see, what have I figured out here? Angle A, the other option instead of this guy is the what? 114.7 degrees. Angle C, which is the other one I didn't know. The other option would be 9 degrees. Obviously, if this is obtuse, this is going to have to be fairly tiny, because that's a pretty big obtuse angle, and we already have 56.3 over here. All right, and then the last step, just like before, is we actually have to solve for C. So I have sine of 56.3 degrees over 7.6. Sine of, and let's see, what is that value now? Sine of A is what, 114.7 over 8.3. And then we have sine of the 9-degree angle all over C. Now again, you could cross multiply using those, but you know, if I made a mistake here, you know, I guess it's here too, so it doesn't matter, but I tend to go with my original angles, but it really doesn't matter, so you can do whatever you want, but I would probably do those two, kind of skip this little thing, and that one. So again, multiply these two, divide by this, and you don't need to use inverse sign or anything because you're actually solving for a side here. And that ends up being, I think I got 1.4 for that side. So there's my two triangles. I know the three angles in this first one, and I know the three sides right there. And then in the second one, I also know three angles, those two, and then my original, and I also know my sides, the two sides I was given, and the new one.